Okay, so thanks everyone for joining us on today's webinar. Very much appreciate your time. Hopefully you're all seeing my screen and can hear me okay. But do let me know if there's any issues. Just by way of introduction, I'm Rob Shropshire and I lead the sales and marketing side of Origin. I will be running the session today and will be your point of contact moving forward if you do want to chat to us in any more detail. Tim Dukes is the other co-director of Origin, and he's focused on basically the support and training of all of our customers, and also shapes our product strategy in terms of the technology that we work with. Unfortunately, due to personal reasons, Tim is unable to be with us today, but he has pre-recorded a demonstration for us to have a look at, so you will get a very good overview of the solution, hopefully. I am pleased to be joined by Peter Kelly, who is the sales director for Ansys Discovery, and there's a wave, and he'll be on hand to help out with Q&A towards the end. So I do like to keep introductions pretty short. You're all here to look at the software, of course, but I do think it's important to set some context in terms of why we exist and what challenges we help our customers solve. We'll then provide an introduction in terms of what Discovery is and how that might fit in with your design workflow before jumping into that demonstration to have a look at the solution in action. We hope the session rather is interactive, so please feel free to keep asking questions throughout, and we will make sure that we save some time towards the end. So Origin have around 200 customers, all of whom are in the manufacturing space. I think what's unique about Origin is that we are focused on the design side and basically advocating for simulation much earlier in the design process. We know that most companies will do simulation or perhaps outsource it, but typically that's later in that product development cycle. And we think by not utilizing it earlier, companies are missing out on the potential time and cost savings. So, we think simulation should no longer be the sole responsibility of CAE experts, when actually empowering designers with easy to use tools can help designers make better decisions and hopefully better products. As well as providing the software, we provide local support and training services here in the UK. The product we'll show today is, of course, from Ansys, and we're really proud to be one of their partners. When we look at technology that we provide to our customers, we do like to make sure that it does have a low initial investment and also a very low learning curve. We're aware that engineers typically have to use a variety of CAD and simulation solutions, so being able to deliver a return on investment for the management team quickly is really important, especially as there's often lots of different solutions and hardware that will be competing for that same pot of money. So, as I said, we believe simulation should be incorporated much earlier into the design workflow. By allowing simulation to be done earlier, design engineers can explore multiple concepts very quickly. Perhaps they want to assess how a particular material might behave, maybe picking a cheaper alternative, delivering similar characteristics, but at a reduced price. When they're designing their products, if they can get some immediate feedback on perhaps a factor of safety, they're able to optimize their designs accordingly. If they have 3 ideas, they can quickly find out which one is likely to be the best design for its intended use. So they can avoid a lot of the expensive prototypes, perhaps physical testing, and generally save time throughout that development process. Another interesting idea, which I'm certainly passionate about, is being better than your competition. If you're proposing a product idea to a client in a competitive situation, if you were the buyer, would you work with the company that was able to show a simulation of how that product is likely to behave in the real world? Or would you buy from a company that just provides you with a 3D model? I'll let you think about that one. Another interesting thing which we've seen in our customer base is actually they're starting to increase their service offerings. They're starting to offer simulation perhaps as a service, which allows them to attract new customers or maybe just get more business within their existing client base. So engineering.com conducted an independent research report where they reached out to manufacturing companies to understand a little bit more about how simulation solutions are currently being used and perhaps why they're not being used earlier in that design process. So we'll have a quick look at some of that now. So if you look at the current situation, only 17% of organizations are using dedicated simulation tools. Not very high in my opinion. 14% just don't bother and leave it up to experience or pure trial and error. 48% do use simulation, which is typically just bolted on to whatever their existing CAD package is. On the right hand side, you can see that designers are the lowest adopters of simulation technology. And simulation is being used more when it comes to the simulation of manufacturing methods by manufacturing engineers. So plenty of room for higher adoption. And we think just like companies years ago have moved from 2D design to 3D design to achieve greater productivity, simulating earlier in the design process, we think can offer the same sorts of benefits. The research then looked at the benefits companies were experiencing. So if you are trying to build a business case, this is quite useful. Interestingly, the benefits didn't really change depending on the job role you asked, whether you asked engineers or the management team, although engineers did place quite a bit more value in terms of continuous improvement and being able to refine their products. In every case, businesses were experiencing a faster time to market and lower costs. And in a world where costs keep rising and competition is fierce, businesses of all sizes, we think, should therefore consider this. So the previous two slides set some context in terms of where the opportunities are, but many on the call will not be surprised by those benefits. Perhaps I'm preaching to the converted. A lot of people actually need to try and justify the investment and why that investment makes sense to their management team. And traditionally, simulation tools have probably been quite hard to use and probably pretty expensive. And because of that, coupled with the investment in training that typically goes on, simulation has been left to the CAE experts. And this does cause some bottlenecks in terms of development, as designers often have to wait for that feedback in terms of simulation results, especially if they're outsourcing it as well. And simulation experts themselves end up actually running lots of quite routine simulations, which designers could have just done in the first place. So we believe, let's give designers the tools that they need to run their simulations and explore their design ideas and whittle down those design ideas. And then let's have CAE experts potentially apply their experience a bit later downstream, where hopefully they can have more of an impact. So as we know, a lot of cost is locked up in that early stage product development process. So with our customers, we hope that you can simulate earlier and hopefully reduce some of the cost in terms of delivering products and hopefully get them out to market a little bit quicker. So there's a quick introduction in terms of what we do and why we exist. Let's have a brief overview of what Discovery is, and then we'll get into the demonstration. So Discovery provides out of the box all of the main simulations that you'd want to run. So we include structural or FEA, fluids, CFD, and also thermal analysis. We also include some topology optimization there as well, which we'll cover a little bit later on. And in terms of why Ansys Discovery, I mean, there are obviously lots of other simulation products out there on the market, of course. We think Discovery is unique because it gives real-time simulation. We think it's the fastest tool on the market in terms of exploring those design ideas. And the reason for that is because it runs on your GPU or your graphics card, and it auto meshes it in the background for you. So it's very, very quick to get feedback on your design ideas, and you'll see that a bit later on. It is easy to use. Typically, a day's worth of training is more than enough for our clients to get up to speed and start running simulations. And we do offer a variety of different licensing models depending on what suits you, whether that's buying it outright for a perpetual license or leasing it. So, you know, we think it's quite easy for customers to get on board and utilize this technology. It's a dedicated simulation tool. So as we've seen, CAD embedded simulation add-ons are quite attractive. I guess it's just because you can add something on to what you've already got. However, we would suggest that actually a dedicated simulation tool we can deliver, we think, at a similar price, but it offers more efficiency because you're not actually locking up that CAD license when simulations are being ran, so you can continue to use that for other purposes. Also, a dedicated simulation tool typically means it's file agnostic, so you're actually able to bring in whatever file types you need, and particularly if you're dealing with customer data, that becomes really important. So let's talk a little bit about the workflow in Discovery, and then we'll get into the demonstration. So it always starts with the geometry side. So Ansys Discovery does come with a full 2D, 3D drawing package, so you can create the geometry in here if you want, but we do know that lots of people may well have existing CAD tools. So we do make it possible to import pretty much any file type, CATIA, SolidWorks, Creo, AutoCAD, STEP, and even faceted data formats like STL. So you can bring the data in, you can run your simulations, but because it is a full direct modeler drawing package, you're actually able to very quickly prepare that model for simulation. So in the video, you might see things being moved around, holes being filled in, wall thicknesses being amended. So it's really easy to work with geometry, get results, and then refine the design again before running your next simulation. Once we're happy with the geometry and we've prepared that, we can then go and get some really fast results. In this example, you're seeing a fluid example. So it comes with FEA, CFD, and thermal, and all of the meshing is done in the background for you. And as I said, the simulation runs off your graphics card, so it's very quick. From a material standpoint, we've got a library of materials for you to choose from, but you can also add your own custom materials into the library, or even if you want, get access to the Grantor materials library as well. So it's really great at being able to quickly get some feedback on those design ideas and iterate the design and run multiple simulations. I also spoke about topology optimization, so we do give you the ability to work with the design and optimize it. Perhaps you're wanting to reduce weight or materials while still working within those manufacturing constraints. So you will see an example of that as well. So it's great for exploring design ideas, but for those that might require a bit more control over the mesh, we also have that covered. So there is the ability to set global or local mesh settings on different parts of the model if you want. And it's also possible to utilize higher fidelity solvers from Ansys Fluent and Mechanical Pro as well. So that's why we think right from design going towards the end of the product development, we've got the technology in place to go and support that. Now, some people on the call may perhaps have experience with or maybe even use other Ansys tools as well. So we do have that covered. We think Discovery is a really nice looking user interface. It's perfect for preparing the models, getting feedback on design ideas and setting up those physics in the first place. But if you really did want to push that through into other Ansys products, you'll see that there's a ribbon at the top which just allows you to click one button and transfer all of that geometry and physics into one of those other products ready for simulation. So to the demo then. So just in terms of what you're going to see, to start with just some brief overview over some of those geometry tools that I spoke about earlier. We'll then move into an FEA example, a CFD example, and a thermal example. All of the results will be run live for you. We've also got a topology optimization example for you. And if anyone is on the call today that's dealing with faceted data, we're actually going to show running a simulation on an STL file as well. So I'm just going to start the demonstration now, so just bear with me.
Hi all, I'm Tim Dukes and I'll be taking you through the Ansys Discovery demos. Apologies this couldn't be done live. Hopefully that will mean less mistakes. First of all, we'll just start with the user interface of Ansys Discovery, and then we'll get into some of the geometry preparation tools and creation/modification tools. We'll then look at a structural example, FEA, then go on to a CFD example, and then into a thermal and hopefully a topology optimization example as well. That should sort of explain the speed of Discovery, being able to do all of those simulations, hopefully in around 30 minutes-ish. But first of all, we'll start with just quickly go through the user interface. First of all, Ansys Discovery has sort of three modes of working. You've got your model mode, which is where you can do all your geometry creation, modification, preparation. You've got your explore mode, and this is the mode that we'll be focusing on most. This is where you can do rapid exploration and rapid simulations, instantaneous results. And this is using the GPU, the graphics processor. We've then got the refine mode, where you do get full mesh controls. And you can go into higher fidelity results, and these are obviously using the Ansys full Ansys solvers under the hood. Any of the simulations or setups that you see we do in the explore mode can be taken straight into the refine mode and run, but obviously due to time constraints we'll just be running these in the explore mode and hopefully getting some results for those. First of all, very first thing we'll look at is just our import and export options, because we can open files from most formats. So hopefully you can see here we've got your ASYS, your 2D AutoCAD, all your CATIA formats, Creo, IGES, Steps, JT, SolidWorks. Most CAD formats you can think of, we can import into Ansys Discovery. So the first thing, just to quickly go over the UI, we've got a number of tabs along the top. We've got our design tab. This allows you to modify and create geometry. We have got a sub-D tool, which allows you to create sub-D models or turn previous models into sub-D and modify them that way. Display tab does what it says. We have the measure tab, again, allows you to take measurements from things. A facets tab allows you to work more closely with STL files, and we can actually run simulations on STL geometry as well. We've got a repair tab. Sometimes if you bring a model into a CAD or analysis tool and it's not a watertight solid, or it's got corruptions, you do need to repair it before you run a simulation on it. Then we've got our prepare tab. So this is a geometry preparation tab. Great tools in here are tools like things like volume extract. Obviously we've got imprint edges, enclosures. So there's a number of tools in here that will help with your geometry preparation and setup for simulation. And then we have our simulation tab, and this is where you will create a simulation depending on what you are looking to create, whether that be a structural, a fluid, or a thermal. And you can also do this via this quick access toolbar here. So all these tools you see in these tabs will also be here. The first thing I just quickly want to run through is some of our design tools and modeling tools. So geometry preparation tools. So I've just imported a model into Ansys Discovery. It doesn't really matter if we're in the model tab or the explore tab or any of the other tabs. You can use all these tools in each mode. So I'll just go into the model mode. A lot of the time, if you are meshing a model, you might want to refine your model a little bit, remove small faces, especially embossing and engraving, or you actually might want to change your model in some way. So we have tools to do all that sort of thing. So for example, in this model, I can clearly see there's a bit of embossing and engraving. In the explore mode, we don't actually need to defeature anything. We would be able to run a simulation on this model. But if you wanted to go into refine mode and make sure you don't have any mesh issues, you might want to start removing things that aren't really necessary for the simulation. So first of all, we could box select this embossing here, and we can use one of our defeaturing tools, which is the fill tool, and that would allow us to actually just get rid of that very, very quickly. Another great tool in Ansys Discovery is the feature select, power select, we call it. So for example, I've clicked on this radius here. Using this tool here, I can actually search for all radiuses of the same size, so I can find all the radiuses in this model that are 1 mil. I can see that I've picked up on 32 faces. Hopefully you can see them all highlighted there. If I did want to get rid of them, I could literally use this fill tool again, defeaturing tool, and you can see that all those 1 mil rads have now actually disappeared. Another nice thing is we can use some of our other geometry tools, such as pull. For example, if these holes weren't meant to be 5.461, they're meant to be 6 mil, or you wanted to make a quick geometry change, you can see I've just selected them both, typed in 6, and now the model's updated. So I'm just making these live changes on the model, and this is again great for rapid exploration of models when doing simulations. So if you run a simulation on this, a structural one, and you find that maybe you need to make a quick change, maybe I need to change the height of this area here, I can use my move tool very quickly, increase the size of this to suit, and I can maybe make another variation and the model's slightly higher. So we're just making those quick design changes, and all this is possible in Ansys Discovery. That's just a very, very quick intro into sort of model prep, model creation, and we can create models from scratch as well, and simplification. But obviously what we're going to move straight into is an FEA example. So I'm going to open up a model, and we're going to look at a structural simulation. So I've just opened up the model for the structural or FEA simulation. First thing I've done is I've used my quick scope tool in the simulation tab to basically specify the pieces that I actually want to run a simulation on. So I've chosen these 4 highlighted pieces here. What I'll do now, just to separate everything, is do a hide all suppressed, and that'll hide everything that's not actually involved in the simulation. Another way of doing that is basically through your actual structure tree, and you can basically just turn off the things that you don't want in the simulation, and include or exclude the ones that you actually do. So now that we've done that, the next step is to actually start applying some structural conditions. And the first thing that I'm going to do is apply some supports. So I'm going to apply a hinge support through these 2 faces here. So we can do this using our little tool guide here, or we can go to our structural tab along here, and then we can go to our supports. And in this instance, it's going to be a hinge support. So I'm going to hit the tick box, accept that. And as I do that, we can see our tree, our physics tree on the right, start to be created. So I'm going to apply a few more supports. Let's do one for here and here. And let's do the final one through these 4 pieces down below here. So we've applied our supports as such. And you'll notice that I've applied these coaxially, so obviously we couldn't apply them all together. Only the ones sharing an axis can be applied as hinge supports. The next thing to do is, before I go on to add a force somewhere, I'm actually going to do a bit of defeaturing. So looking at the model, there is still some little 1mm rads along this edge, and if I look at the bottom side, they're no longer there. So let's use our power select tool to quickly defeature those. So if I click on the face and use my power select tool down here, I can select all the rounds equal to 1mm. You'll notice that's picked up on 72 faces. We can go into our design tab and hit the fill tool. We can see those instantly get removed. Now let's do a bit of defeature on this thread. So obviously I might not want that thread there, especially if I'm going to mesh this part later on. A thread might get in the way, it might not be necessary. So let's do a big box select around this whole area, and then I'm going to hold control and deselect this area here. Let's just turn off our power select tool, and that should allow me just to fill in this thread up to this line here. So again, I'm going to use the F key or the fill tool, and that allows me to fill in that area there. So again, just defeaturing, preparing that area for simulation. So next step is to apply a force. So I'm going to apply a force to these 2 faces. I'm going to use my quick access guide here. So I'm doing a structural simulation, and then I can apply the force tool as such. So I'm going to apply it here, and I can type in negative or positive values. So I'm going to apply a negative 2000 in the X direction, or minus X. I'm going to apply a positive 10,000 in the Y direction, and let's do a negative 2000 in the Z. So you can see you can apply these any way we want, or we can use a remote point. Once happy with it, let's just hit the escape key a couple of times, and now we can see our force has been set. One thing we're going to look at now is the contacts. So if I look at my bonded contacts here, if I double click, I can see at the moment I've got 3 contact pairs, and we can see them by these little points here. I don't want all these to be, and these are at the moment bonded, so I might not want all these to be bonded. So I'm going to set this one here first to permanently bonded, as I want that to be that. These other 2 I'm going to actually exclude from contact detection. So I'm going to use this tool here, and they're going to be excluded from contact detection because I want to create my own contacts. So again, to do this, I'm going to first select on this point here. I'm going to use my quick access guide. I'm going to set up a joint, and selecting this tool here allows me to select secondary faces. I'm going to select these 2 as secondary faces. I'm going to hit the tick box. So I've created my first fixed joint for there. I'm going to do the second down here. Hit the tick box, and just do the same on the opposite side. So those are all my joints connected. One nice new feature in the latest release is the ability to actually add a spring joint. So when we saw our parts, we can see that there's actually a couple of springs. So we can apply these using our spring tool. So we can again use this tool here. This is the new spring tool. Select a secondary location. In this instance, I've actually created a point in space, and we can select longitudinal or torsional. I'm going to apply a value of 1000. So that's applied it there. I'm going to do the same thing for this one. Make sure I select the secondary faces here. Again, keep it the same and accept that there. So that's my structural setup complete. I'm still in this explore mode. Just to explain this a little bit here, this is our fidelity bar. If I go into the simulation tab, I can get a bit of a size preview. So this will tell me sort of how big almost my mesh is. Obviously we're not meshing it in this mode, but it will tell you how big the mesh is and give you a bit of a preview. We can obviously increase this fidelity, so you can see I can increase this slider bar, so I'm obviously going on quite a low fidelity at the moment. We can increase that obviously up to the top, and I'm ready to basically get some results. So we hit the solve button, and within a few seconds we're going to start to see some results. So it's still simulating at the moment. We are looking at displacement at the moment. And obviously we can visualize that displacement as well. So we can use this tool here to actually visualize that deformation, and we can animate it as well, so we can see how this part may animate based on my settings and my forces. So we can look at things like, if I just pause that, we can look at things like displacement. We can obviously look at high areas of stress based on our forces. And we can look at that in different values. Obviously, megapascals might be the most common one we use, and we can set our bar on the right hand side to any values we choose to maybe highlight the high areas of stress or just look for particular areas. Up in the right hand corner, we've got things like factor of safety, obviously displacement, stress, but we can also create any, if you want to know a value in a certain area, we can hover over it and you can see it appear in the results bar on the right hand side, or you can actually create a monitor and select a result and have a particular stress value on a face or a hole, and so on. So that's just a very, very quick example of a structural simulation sort of setup through to results, again using the explore stage. And we'll now move on to a fluid example. So I've just opened up the model that we'll be looking at the fluid flow example on. The first thing we might want to do when we're looking at a fluid flow example is, if this is an internal flow, we can also do external flow, but we might want to extract the volume. So in the Prepare tab in Ansys Discovery, we've got a great volume extract tool. So the way this works is we click any face with an opening. So these three faces have got the opening in this model, and then we select a seed face or any internal face. This also works on assemblies as long as your assemblies are watertight. We can extract very complex volumes very quickly using that volume extract tool. The next thing we want to do is actually set up our inlets. So this and this face and the opposite one are going to both be inlets. So I'm going to set up this face as an inlet, and we can specify velocity, mass flow rate, pressure, swirling flow. I'm going to use velocity. I'm going to specify 1 meter per second. I'm going to do the same on the opposite side. And then I'm going to choose my outlets. So these 3 faces here, or 5 faces are going to be outlets. I'm going to specify that as a 0 PA. One thing we can also do once we've created our volume is we can also overextend these outlet faces if we wish. So we can also use our modeling tools. In this instance, I'm using the pull tool, which is found in the design tab. And if we want to, we can overextend them. Sometimes in CFD simulations, we might want to overextend those so there's no sort of turbulent flow at the outlets. So now that we've done that, we can look to our physics tree on the left hand side. At the moment, we're using a water as the material. I might want to change that to air. So let's double click on the water icon, and we can specify a new material. In this instance, we're going to specify air. Another thing we may wish to do is we may wish to actually define the temperatures of these inlets. So for example, if inlet 1 is going to be a certain temperature, we can actually define that. I'm going to let that be 22. Inlet 2, I might actually wish to change this temperature, and I'm going to have this as a higher temperature, and I'm going to change that to 50 degrees. So we're doing a fluid simulation, but we're actually in a fluid thermal now. That's our setup sort of complete. Just to go over another few things. At the moment, we are doing a steady state simulation. In the explore mode, we can actually also do a time dependent or transient simulation. And those can be set up by clicking on this little icon down here, or we can choose it here, and we can actually specify the duration as well. So once we've set up our simulation, we can hit the solve button, and within a few seconds we will start to get some results. So straight away we're getting results. One thing I will just do is I'll make these components transparent. Sorry, there we go. Let's make these transparent just so we can actually see the simulation through them. And let's look at it from this angle. So at the moment we're just looking at vectors, and we can see here our options to modify the actual how you view them. I'm going to change this to contours, and I'm going to turn vectors off. So when we change this to contours, straight away we can start to see how the flow of how the material sort of, or air, flows in this instance, and we can see that the top 2 outlets clearly get a lot more flow than the bottom ones. If you hover over this, we can actually see the flow. If you look at our results bar on the right hand side, hopefully you're seeing a value change as I hover over different areas. So we can clearly see that the velocity at the top area is around 1.5 meters per second. Moving down to the bottom, the second one, we're looking at like 0.6. If we move all the way right down to the last one, we're looking at 0.139. So the flow is clearly directed towards the top outlet. That might be something you wish to change. So if you do wish to change that, maybe you can make some design changes. So let's make that transparent or non-transparent again. And what I'm going to do is I'm going to section this model through this part. So I'm going to select these 2 opposite faces. I'm going to go into what we call a section mode in SpaceClaim. And I'm just going to look at it from this top view. So we can see potentially that if we maybe make some changes to these ribs, will that maybe direct the flow a little bit more downwards. So maybe these 2 here, I'm going to use my move tool. and use my move tool, and I'm just going to make these, maybe bring them back slightly. So I'm just making a direct change to the simulation. The volume will update and we'll start to get some new results. So you can see I've just moved them down, and then we can start to see whether that has a direct effect on the simulation. What we can clearly see now is a lot of that flow is being directed rather than into the first outlet. We can clearly see it's being directed into the second outlet's probably got a higher velocity per second value. So you can see what we're doing, making live design changes, rapid exploration, and seeing what effect they actually do have on the model. So we can continue to make changes. We can try and even this out. We can change the size of these ribs. We can maybe add new geometry to sort of direct this flow more, maybe down towards these last outlets. But you're doing that on the fly. And again, like we did with the structural, if you want to take this into the refine mode or even transfer it to Fluent, you can do this in Ansys Discovery. For our third example, we're going to be looking at a thermal simulation. So for this example, we're actually going to be looking at what we call CHT, or fluid solid thermal. And again, this is another simulation that you can do in Ansys Discovery, and you can actually do this in the explore mode. So again, using that graphics processor to get speedy results and rapidly explore designs. So we're going to start with the setup for this. Again, this is going to be have a cooling channel. So if I just make this part transparent, just so you can sort of see the cooling channel in this part, and then we've got these 3 transistors that will have like a heat source. So first of all, let's extract the fluid volume. So again, we'll go into that prepare tab, use our volume extract tool, select the face with an opening, and select a seed face. So very quickly, we've just extracted the fluid volume, so we can see now that we've got these faces. And we can then start to apply some heat sources to these transistors. So let's triple click on them. Using our quick access guide here, we'll add a thermal, and we can add a heat to these, and we'll add a value of maybe 150 watts. So I'm going to triple click on the second one and add the same value, and I'm going to triple click on the third one and add the same value. If we look to our tree on the left hand side, we can now see that we've got those in our physics setup. So now we need to specify an inlet and an outlet. So I'll use this face as the inlet. Make sure that's set to inlet, and we'll specify a velocity again of 1 meter per second, and let's make this a bit cooler. Let's make it 10 degrees. So now we can specify an outlet and hit the tick box. So that's our fluid solid thermal conditions set up. What we can now do is actually look at the materials as well. So at the moment, again, this is defaulted to a structural steel. These transistors may be a different material, so they might be like silicon. So we can click on here, and we can then search for different materials. So maybe these are silicon, so I can just specify silicon for that one, and just do the same for each one. Set those to silicon. So I can change the materials. You can search for your own materials, and also one thing to mention is obviously we do have access to Granta materials, so that you can actually have an additional module to get access to a massive library of materials from Granta. So I'm just going to leave those as they are. The liquid is presumed as water, so we'll just keep it as that. So we've got these 3 parts of silicon. This is structural steel. Again, you can change your materials to suit. So our setup is sort of complete now. Let's hit the solve button and see what results we are getting. So instantly we're getting results again. So it is still converging, as we can see here. But straight away, just initially looking at this, we can see that the third transistor is obviously getting a lot hotter, which potentially could mean that there's not as much flow getting to that third transistor. So we can look at our high temperature again along here. We can hover over points on the model, and we can see that the third temperature is around 32, Second one, we're looking around 26. The first one, around 23. So we could always put monitors on any of these to sort of find the values. So if I triple click on this one, I could add a monitor, and select a variable, temperature, we'll select average, and then we could say the average temperature of that transistor is 31 degrees. If we now change our results type to velocity, we can see potentially what's happening here. So we can see that a lot of the flow is sort of going around, but not much is getting to this final transistor, which could be causing, well, probably is causing that one to get a bit hotter than the others. So so what we could make some design changes and see what happens if we had quite a drastic design change. So what happens if I actually remove one of these sections, maybe this first one, if I box select this area. Make sure I only select the face that I want, and maybe let's remove it. So let's go to the design tab, and again using that fill tool, let's get rid of that area. So you can see straight away exactly what's happened. I've removed it. The simulation will now start to re-simulate. We can see now hopefully that a lot more flow is getting to that third area, and our simulation will re-simulate. You can still see it's converging here. But we can straight away see here that we've gone from 31 degrees, that transistor, down to 25.9. So let's have a quick look at the temperature. And you can see we're getting a 26, 23.6 in the middle one, and a 26 in the far one. So the temperatures are now, closer to the same, than a bit more average. We could again do a little bit more work, try and get a nicer flow all the way around the part. So that's just again a very quick example of a thermal, and showing you the power and speed of discovery. We'll now move on to a topology optimization study, and finish off with just a study on an STL. So that's just a very quick example of a thermal simulation within Ansys Discovery. So in this simulation, we're going to be looking at topology optimization. So I've just opened a fairly simple bracket component, but this will give you an idea of what you can do within Ansys Discovery in terms of topology optimization. So the first thing we need to do is actually set up a structural analysis. So first of all, I'm going to specify some fixed supports. So I'm going to make sure these two holes are fixed supports. So I'm going to hit the tick box, and I'm also going to specify obviously the opposite two holes, and finally I'm going to specify this as a fixed support. So these are the areas where the part's fixed. I'm then going to apply a mass load to this hole here, and I'm going to give it a value of 75 kilograms. I'm going to do the same on this one. At the moment, because we haven't turned on gravity, that mass is having no effect, so we do need to turn on gravity. And we can do that by clicking on this icon here, and that will include it in the simulation. So before you actually run a topology optimization, you may want to actually get some results, just general results on the actual performance of the part in the first place. So obviously we can just, in our explore mode, we can just run a quick structural analysis, and we can quickly find out some results. So one thing you might be interested in this instance for very quickly is the factor of safety. We can see here that the factor of safety of this part is around 10. Depending on the industry, that might be fairly high, and you might be able to actually cut down on a lot of weight while still maintaining a decent factor of safety. So we can then turn on our topology optimization tools. So I'm going to just turn on our topology optimization by clicking on this icon here, and this should bring up our topology optimization settings. So the first thing, our target. So our target is to maximize stiffness, but we can also use any one of these. And on the right hand side, we can see that we're trying to reduce by a percentage, a volume percentage. And we can also specify manufacturing constraints as well. So if this part is cast or molded, if it's 3D printed, if it's machined, you can set up different manufacturing constraints depending on what you are looking for. Once you're happy with this, and also we've also got our protected regions, and these are here highlighted sort of red or pink, and we can change the value of those if we wish as well. So that's our sort of setup complete. What we can start to do now is hit the solve button, and we can let this run, and hopefully we'll start to see some material be removed from the part. So once this part starts to run, material will start to be removed from the part. After we've hit the solve button, we'll start to see material be removed live, sort of in front of us on the model. So we can start to see the material sort of take shape and evolve as it's trying to remove more and more material to make the optimal shape. Whenever you're happy with this model, again, it'll keep going until it's hit your material target. But if you're ever happy with it, we can always pause the simulation, and then we can actually transfer the optimized body to the model. Once we've done that, we might want to run a validation simulation. So if I was happy with it at this stage, I won't run it until the end, just for the purpose of time. So I'm going to hit the pause button, and I might be happy with it as it is there. I'm then going to click this tool here, add optimized body to the simulation. And what this has done is it's obviously created sort of an STL mesh body. If we look in our tree up here, we can do a couple of things. If we right click on this, we can actually create a validation simulation on this part. So if I click this, this will transfer all the simulations to this new mesh body. And then we can actually then solve it. So we can hit the solve button. It'll then run this on this new optimized part. One thing obviously it didn't do is do a mass part on the part, but one thing we did do is we know that our factor of safety has decreased, but is that still within target for the industry we're in? Maybe it is, and this could be a more suitable part. So, so that's just a very quick example of topology optimization in Ansys Discovery, and we'll finally try and look at running a simulation on an STL, an actual STL body. So the final simulation is going to be run on an STL body or a faceted body. If we look in here, we can see that this is a triangulated body made up of a number of different triangles. We're going to run a very, very quick fluid flow example on this gyroid, but you can also run structural examples in exactly the same way. So first of all, what we need to do is set up a faceted region. In this instance, I'm going to set up two, my inlet and my outlet. If you were doing a structural, you could set up regions as your supports, where you're going to apply forces. So to do this, I'm going to double click on this area here, and I'm going to right click. I'm going to say add facet region. I'll do the same on the opposite side. Double click too much times and add facet region. What that means is when I hover over it, you can see that rather than one STL, it's selecting the whole thing. So let's add this face as an inlet. And let's just give it another value, let's say 2 meters per second. And then let's add this region and make sure this is my outlet. So my simulation is ready to solve now. I should be able to hit the solve button on the right hand side. Within a few seconds, we're going to get some results. So straight away, we can see we're getting results. We can see again at the moment, we're just looking at vectors. We can turn that off. We can look at contours. We can look at a direction field. We can look at particles, and we can start to see how the fluid flows through this part. So that's just a very quick end. I just wanted to show you that Ansys Discovery can also run an STL data in the explore mode. As mentioned previously, there is a separate mode for the refine, and this obviously gives you full mesh controls, and you can obviously run potentially at higher fidelity. And that's the sort of end of the demo. Again, thank you for attending, and thank you for sort of watching the demo. Hopefully you found a few things useful in there. And if you've got any questions, this is the sort of time to ask them. So please do type them into the question box, and Rob and Peter will be able to answer any of those. Thank you.
So thanks everyone for watching that. I'm just going to start sharing my screen for one last time. Apologies for anyone that did hear a naughty word in that demo. I'm hoping no one had their children watching the simulation scenario, but at least we're authentic. I think Tim packed an awful lot in there. Hopefully it wasn't too much. I think what we were really keen to do was just show the breadth of the solution. So let's just wrap up over the next couple of slides. And I've started to see some questions coming in. We'll still have 5 minutes to answer questions, so please start firing them across. But I hope that what you've seen is that it is a tool that is suitable for a designer. It's very easy to use. It has all of the simulation that you need, but it's also scalable. So you've got this concept of being able to quickly evaluate those design ideas, get feedback, iterate design. But of course, you can use higher fidelity solvers and control the mesh in more detail if you want. Today, we just haven't had time to go through all of that, but we're more than happy to cover that off separately. I think what I love, and I'm biased of course, but I think that Discovery, it looks nice. I think it's a pleasure to use. So, you know, being able to set up and run your simulation scenarios, even if you are using other Ansys solvers, is really powerful. So hopefully it's more of a modern day interface, one that you'd be used to in your personal lives. We've crammed in a lot, but as I said, hopefully you know, there is a lot more, but hopefully you've seen it is a complete solution. You know, we haven't really covered the fact that it's a full 2D, 3D drawing package. You've got all of those file import options. You've got FEA, CFD, thermal, topology, and obviously a lot of other features we've not talked about today. So if you do want to engage, I am going to start I'm asking some polls, so you'll see some questions that we're going to ask. So if you are able to answer those as a way to decide if you want any more information and just some general questions we'd love to hear about. So I'll turn those on when we get to Q&A. If you go across to the polls, then you can answer those questions. But we're more than happy to provide a more tailored demonstration. Typically, it's useful to use one of your parts. Perhaps you want to check the types of simulation results against a project you've already done, so you can sort of compare. We are offering free trials of the product, and we're very happy to provide some complimentary consultancy as well in terms of getting you up and running and providing a whistle-stop tour of the software so you know how to use it. And as I said, we do have quite a bit of experience in terms of helping people build business cases. A lot of you on the call today have attended this because you're interested in simulation. You can probably see the value already, but a lot of the time it's trying to get management teams to invest in the technology. So we're more than happy to help you with that. I'm just going to leave the details on screen now with our details, and I'm just going to share those polls. You can answer them. But Peter, I wondered whether you could start answering some of the questions. The first of which is from Gordon. Can the structural part cope with composites?
Yes, I've been typing in some answers so far.
Okay.
So the first question was, just to clarify, it was someone asking, it was just asking whether this works for structures as well. And I was presumed he was referring to the last part of the demo that Tim was doing, which was on the STL data. And the answer to that is yes, you can do the structural analysis on the faceted data. Obviously, faceted data is just, in essence, an external sort of shell. So it presumes that the internals is solid. Even if you looked at it in cross-section, you'd see no solid there. The presumption is that it presumes solid throughout the internals of the shell of the facet. You're doing your polls. Let's just go back to the chat. So there was a question about composites. There isn't anything specific. There's no specific composite approaches and support within the software at present. So, you know, if you've got multiple layers with directional plies, that does become the domain of a pretty high-level FEA analysis, specifically for composites. But, you know, let us know if there was anything specific you were wanting to do as to whether any of the generated results from Discovery might offer some some relevance, some pointers. So let us know the specifics of that. You've got, can the Euro code be applied when doing structural analysis? So I'm not precisely sure what part of Euro codes you're referring to. You've got then, can buckling of beams can be checked. We do report on the Discovery forum. There's a document that reports the difference between the Explore mode, the GPU powered simulation mode, and the Refine mode, which is your classic FEA mechanical powered simulation. And there's a couple of beam examples in there in terms of how the results compare between the two. In simple terms, as long as the granularity of the beam can be captured within the automatic voxel mesh that's generated for the Explore mode, then the results can be pretty effective. Obviously, if the voxels don't capture the granularity of, or the distance of the thickness of the material, then the results shouldn't be considered appropriate. But that's part of the reason why both the Explore and the Refine mode is within the product, that you have both options. Refine is classic ANSYS mechanical quality calculations. Let's see what else.
I think there was just another question, yeah, just to explain the way it's meshing, Peter, in both Explore and Refine. I think would be useful for everyone, because there's a few controls questions on that.
Yep, no problem at all. So the Explore mode, which is powered by the GPU, as I mentioned, it's a voxel-based approach. So basically, it's a volume of squares across the extents of the geometry. So it bounds the geometry and then fills a granularity of voxels across that geometric space. And the granularity is based on the amount of graphics, the GPU RAM that you have available, and the number of cores you have available. So it's because the GPU is in essence like a multi-core parallel system. We're using the CUDA library in the NVIDIA graphics card, which is a library facilitating parallel processing. And that's why the simulation is so fast. But it does have a limitation in terms of the granularity that you can study. So as an example, very large distances and very thin material would be difficult to capture that granularity. So in that scenario, you might have to split up the geometry and analyze it in a different way. The Refine mode is classic ANSYS mechanical, or classic, the classical FEA process in many tools, where you define a mesh. We use sort of very physics-friendly, user-friendly mesh generation, but you can control that as well, as Rob said earlier. So you can either globally define your mesh type, and you can change the type, so you can take more effective curvature, or across thin wall parts, you maybe want to have multiple mesh segments so that the thickness of the material is captured correctly. So you've got control of that within the Refine process. The Explore, no control at all. Basically, it does what it does. And we show, I don't think Tim showed it, showed it briefly, the size preview, but there's also a resolution button within the fidelity mode. You can toggle those on to get an indication as to whether the voxelization of that mesh space is going to give you effective results or not. But apart from that, you can't really control it, other than that simple fidelity bar along the bottom. But that basically just gives you finer granularity or cruder granularity. There's no real control of it to sort of model or manipulate across the geometry. We can share that in more detail one-on-one if anyone wants to dig in behind that.
We're out maybe one more. Do you offer cloud-based simulations to help with the larger simulations in terms of cloud resource for?
So the answer is yes. I mean, ANSYS has quite a good cloud strategy. So you can contract and use Discovery on the cloud, both GPU and CPU based for the Refine mode, GPU for the Explore mode. You can offshore cloud-based calculation is typically more relevant for the Refine mode. If your simulation run in Refine mode has taken, 1 day, and you want to bring that down to 1 hour, and you don't have HPC resource, then outsourcing that to a cloud infrastructure where you've got 124 cores or whatever can reduce that simulation time very quickly. Less so on the GPU mode, as you saw from Tim's demonstration. The GPU results are returned very promptly, within seconds. Less so with fluids. You do have some convergence. Some convergence cycles take longer to actually, produce a valid steady state result. But in general, hopefully you saw that today. Almost every simulation you run, you're seeing results of some nature back within 3, 5, 10 seconds. So, but yep, full cloud infrastructure if you're interested.
Thanks, Peter. So we're running over time. There is one quite long question, which we've got your details, Sagan. Hopefully I've pronounced your name right, but that's quite a long question, I think. So we will have a look at that and see if we can get you a proper response back via email, and we're happy to chat about that. If anyone's been too shy to ask a question on here, or perhaps we haven't got round to answering it, our details are up there, so please do get in touch. For anyone that does want to share the recording, we will make a recording available for you, so you will get an email, and you'll probably get a follow-up or call probably from me, and very happy to chat further. So once again, thank you everyone for your time. Thank you, Peter, for answering the tough questions, and we hope we'll hear from some of you fairly soon.
Thank you.
Thank you.